This is a recap for Tuesday, December 8th. We worked on CAMI week 12 today. So the target on page 1 is to review number operations. Write each number as an improper fraction. Follow the rules for adding, subtracting, multiplying, and dividing fractions. And write the answers in simplest form and convert answers to mixed numbers if needed. We talked a little bit about the idea of a rule in math is a little different than rules like laws that you follow when you're driving or other good ideas. And it's really more like procedures, like practical procedures to get to correct answers. So I don't want you to think of rules kind of like things that you have to follow or you're supposed to follow. It's procedures that make it practical to get to correct answers. So let's do these 3 problems. So this is 2 1/4. We'll change it to an improper fraction. That's 9/4 plus 15/8. We need a common denominator. We can think of the fourths as the size, the denominator as the size, and the numerator is how many you have of that size. So we have different sizes here. So we're going to change 9/4. We're just going to double the 4 to an 8. So we have to double the 9 to an 18. So now we have the same size, 18/8 and 15/8. So they're all 8s. So we just have to count up how many we have. So mathematically, this is asking how many 8s do you have if you have 18 of them and then you add 15 more. So that's 33 of these. So that simplifies to 4. 8 goes into 33 4 times with 1 left over and 1/8. 4 and 1/8. When we did this one in class, I want to show you 2 different ways to do it. One, and we had students demonstrate today, which was fantastic. One way is to make the 8 into a fraction and change the 5 3/4 into 23/4, and then multiply the 1 by 4 and multiply the 8 times 4. So we have 32/4 minus 23/4, which is equal to 9/4. And we can simplify that to 2. 4 goes into 9 twice with 1 left over. Another really nice way that a student suggested was to change the 8 into a 7 4/4, and then just subtract 5 3/4, so we wouldn't even have to borrow. 7 minus 5 is 2, and 4 minus 3 is 1. So kind of a simpler way to get to 2 1/4. And that brings us back to talking about the rules. If we think of things you're supposed to, like you're supposed to do it this way, right here, then you're going to think that that is a mistake. You broke the rules. Or if you think you're supposed to do it this way, if you do it this way, you broke the rules. And that's not true. So what we want to concentrate are on concepts. And the concept here is that you can change the format of a number, but the value stays the same. So 8 is the same as 7 4/4. And that flexibility is vital and important in math. So let's do this one. This is 13/6 divided by 3/10. Each period today, a student demonstrated how to do this. We're going to change this to 13/6 times the reciprocal of 3/10. A reciprocal is a number that you multiply by to get 1, and 3/10 times 10/3 is equal to 30/30, which is equal to 1. So we're going to multiply this by 10/3 and we'll get the same answer. So this is equal to 130/18. So let's see if we can pre-simplify here a little bit. Let's see. 2 goes into 10 5 times, 2 goes into 16 3 times. So we could simplify that to 65 ninths. 9 goes in there 7 times with 2 left over. 7 and 2 ninths. And then we talked about using the order of operations to simplify expressions. And that grouping symbols is the same as parentheses. So if I do this, parentheses 3 plus 5, that's the same as a bracket, 3 plus 5. And that's the same as a fraction bar, 3 plus 5. And what we want to see on your paper is kind of a funnel. So first thing we want to rewrite these as we work on them. So let's go back to black here. So we're going to do this part first. So negative 5 combined with 3 is negative 2. So this is 4 times a negative 2 minus 7. There is a implied multiplication. So when we have a number next to a parentheses, that means multiplication. 4 times negative 2 is negative 8. And we spent quite a bit of time today on this right here, negative 8 minus 7. One of the most difficult concepts in 7th grade math. So we're going to try to write an equivalent addition problem because I think it's a little easier to see it as addition as long as we get the same answer. So this one stays the same, negative 8. We're going to add the opposite of this. The opposite of 7 is negative 7. So that's equal to negative 15. So that's equal to negative 15. So negative 8 minus 7 is negative 15. And let's do one more. This grouping symbol acts like this fraction bar acts like a parentheses. So it's the same exact problem as this. Negative 5 times negative 7 plus 14 parentheses divided by another parentheses 2 plus 5. So it's the parentheses down here and up here. So mathematicians like to use the fewest number symbols as possible. So instead of using all those parentheses to put it into groups, we can just put one line. And let's get a red pen because what we want to do is go like this down to one answer. So the first thing we're going to do is negative 5 times negative 7, that's 35. Go to a red pen. So 35 plus 14, and we'll keep this grouping symbol, which is like parentheses, 2 plus 5. And we'll do 35, 14, which is 49, divided by 2 plus 5. And then we'll finally do 2 plus 5, and rewrite that as 49 divided by 7, which is equal to 7. And then we did these two problems. We're going to do this first and rewrite everything else, 2 plus 8 minus 5. Then we're going to do this next, 10 minus 5. It's important that we always go left to right with a multiplication, division, and addition, subtraction. So that one was equal to 5. We're going to do this first, 5 times 4 minus 10. 5 times 4 is 20. 20 minus 10. Notice how I write that down. I don't do 20 minus 10 yet. I write it step by step by step until I get down to one answer, one number. And we'll work on some of those tomorrow. The other thing that we did today was work on iExcel. And I'm going to pull out my drawing tool. And there's a couple of different thoughts on this, on changing between decimals and fractions. So if I have 3/5 and I want to write this as a decimal, what I want to do is I want to have it written so I can say it using place value. That's the tenths place value. So if I can have a 10 right here, then this is what I say right here. So 5 times 2 is 10, 3 times 2 is 6. So 6/10 is like this. If we can get away from saying 0.6 and say 6/10, then we can get those correct by just reading them. So 6/10. Okay, 3/4 as a decimal. Here's how we're going to do this one. It doesn't work quite as well, 3/4. We want to get to a 10, but if we can't evenly get to a 10, we could try to get to 100. So 4 times 25 is equal to 100. So we do, to keep it equivalent, 3 times 25 is 75. So that's going to be 75 hundredths. So this is equal to 75 hundredths. Really practice saying that instead of point, and you should improve on this quite a bit once you just practice saying place value. Okay, I can literally just say this one 9/10 as I'm submitting it. 2/10. So I can say the fraction 2/10. Okay, so 3 and 75 hundredths. So 3 and 75 hundredths. And this one doesn't require that you simplify the fractions. 9 and 9/10. So say it, listen to it, and type it. Okay, now this one is a little bit more challenging. So as a decimal, 7/8. So to get 8, it doesn't go evenly into 10, doesn't go evenly into 100. You're going to have to go all the way to 1,000, which you can do. Or you can just do 7 divided by 8. So 7 divided by 8. Doesn't go in there evenly. We need the decimal point. Goes in here 8 times. 6 left over. You just have quite a few zeros until it evens out, or zeros out, I should say. Okay, 7 times 8 is 56. And 8 times 5 is 40. So that's zeroed out. Once you get there, you're done. So this is 875 thousandths. That's the decimal. Okay, 0.875 thousandths. And I forgot the 15. I would have got that wrong. So 15.875. We'll have this be our last one. Okay, and that is a recap. Hopefully you're working on Pear Deck. We're going to work on that tomorrow. So recap for Tuesday, December 8th.